Good morning, everyone. I'm so excited to have you here today. We have Justin Arana here from Western Construction Systems, LLC. He comes highly regarded from the Professional Development Key Committee. So we're excited to have Justin here to talk to us about foundation repair. Welcome, Justin.
Yep, thank you for having me. Again, I am Justin Arana. I'm with Western Construction Systems. I am on-site inspector and project manager. Our company specializes in foundation repair, structural, and drainage. So we are not a general contractor, but we do all types of foundation and concrete work, including crawl space restoration, vapor barrier, sump pumps, all types of drainage work. So I'm going to go through a standard slideshow presentation here. Just talks about kind of every aspect of the scopes of work that we do pretty much on a daily basis. And this is kind of designed as a interactive presentation. So I highly recommend, if anybody has any questions, to kind of shoot those on over, and hopefully we can answer that for you. I know foundation repair is a big scary thing out there when it comes to real estate. You never know if it's a $20,000, $50,000, or something very simple little thing. So I'm going to kind of go into all that and just kind of describe what is really what you can look out for, what are real concerns to look out for, what are things you can kind of talk to your clients about. And we really come in to just give the best overall honest and reasonable solutions for really what's necessary, what really has to be done, to extend the life of the foundation and to, make everybody feel comfortable. So we'll go here, move forward here. Let's see. So foundation repair and restoration. So typically the homes that we work on are older homes, like pre-1950s, and even the majority of those are in the 1920s era. All of Portland, Northeast Portland, we do service the entire state of Oregon and Washington, but pretty much the main scope of work that we do is needed in older homes, because that's when we start seeing failure and damage to foundations. So restoration and repair, you'll see spalling and deterioration due to very soft concrete. So back in the day when they poured these foundations, the concrete mix had a lot of sand in it, which creates for a very soft, porous concrete. And over the course of 50 to 100 years, that concrete starts to break down and deteriorate. So that's when we come in to restore those walls, strengthen the concrete to extend the life of the foundations in lieu of full replacement. Typically, concrete is only really designed to last about 100 years. So these 1920s or earlier, even late 1800s, 1910 foundations are really at the end of their life cycle. So we're coming in to do a restoration process and strengthening applications to, extend the life of those, give them another 30 to 50 years of life before it needs to be fully replaced. This picture here is showing some exterior repair that was part of a stem wall that was partially below grade. You can see the little concrete footing down below him there, and we're grinding and chipping and kind of prepping the surface. Our application really, the number one most important thing with repairing these old foundations is prep, ensuring that we remove all of the failed materials, the delaminated concrete, to provide as clean and solid surface or substrate as possible. Let's see here. We'll go ahead here. So crumbling, that's something that you see often, especially in older homes and mainly in basements. This picture here is showing a unconsolidated pocket of gravel inside a foundation wall. That's what the foundation, you'll see pockets of those of rocks inside the wall. That's because when the concrete was poured, in the 1920s, they literally were using wheelbarrows and dumping the concrete into their forms, and they weren't consolidating or vibrating the concrete. So you get these pockets of rock. Those are a great pathway for groundwater to seep through the foundation, through that void. This is a very common problem that we see, and we come in and waterproof those, chip out those rocks, remove those rocks to create a nice large void in the wall, and we'll reconstruct those holes or voids with high strength epoxies or mortars. Also, homes of this era, pre-1950s, typically have no rebar in the foundation, so it means they're unreinforced masonry walls. The biggest concern for that is all basement walls are also retaining walls holding back the soil. So it is very important to make sure, or to ensure, that the foundation walls are as stable as possible.
So Justin, if someone, a realtor, was out taking a look at a property and they saw crumbling, would that be a big enough indicator to give you a call?
Absolutely, because you don't know, or somebody on site doesn't really necessarily know, and you shouldn't know or can't know necessarily how bad that crumbling or rock pocket or crack really is. So I recommend that everybody save my personal cell phone number in their phone, and I can't tell you how many times a week literally I'm FaceTiming with realtors in basements, or they're shooting me over a picture. Hey, what do you think about this crack? Or hey, the skim coating's kind of falling off in this area. What do you think? And I'll say, hey, shoot me over a little video, or I'll call you in 10 minutes, because a crack in a foundation could literally be not a structural concern at all, and it could be a major failure. The difference of horizontal and vertical cracks and where the crack is located. Almost all foundations have cracks like coming off of little foundation vents or windows or something, and typically it's really not that big of a deal, but there's a lot of little minor details that we look at to determine really the overall severity. So when in doubt, just give me a call or shoot me a text message or call my office. We run 3 to 4 full-time inspectors a day, and we each do between 4 and 5 a day, and we're typically like 3 to 5 days or more booked out for inspections. So if something's a real time crunch or time sensitive like they always are, we recommend just get a hold of us as soon as you can. And I would say more likely than not, if it's a simple spalling or crack repair, I can almost get you a very accurate, detailed proposal sent over within 24 to 48 hours without having to go out there. But yeah, when in doubt, if you see something that's abnormal or your client has any questions, yeah, get a hold of us for sure.
Cool.
Yep. Let's see here. So this is showing a standard 1920s basement wall. It was skim coated when we got there. This picture is showing the wall prepped and ready for our restoration process. Standard restoration is not necessarily strengthening. What that's doing is greatly reducing or eliminating further damage to extend the life of the concrete. This is a very, very important part of our application, just for cost effective wise for the client, in lieu of like $150,000 replacement job. So we have removed all of the existing patchwork to expose the original bare concrete. It was a hand poured, lots of rocks and gravel and sand in this mix. We rate all of our foundations on a scale of 1 to 10. 1 being a brand new foundation and 10 being a sandcastle. This foundation was about a 6 or a 7, so it was definitely well within the realm of repair, but still pretty bad. Once we have done all of our prep and cleaned the wall and removed all the failed materials, we apply 3 saturation coats of a deep penetrating foundation sealer. This sealer is clear, odorless, non-toxic. It almost looks like water, but what it does is designed to absorb and soak into the concrete and create like a Gore-Tex structure. It creates an interior gel system, but still allows the wall to breathe, but doesn't allow moisture to migrate through the concrete. This greatly reduces or stops the deterioration rate. And then we'll come in and hand trowel our mortar. The mortar that we use typically is specifically engineered and designed to, 1, adhere to this soft concrete, and 2, provide a waterproof barrier. This material at full cure, it's about 10,000 psi. That's the compressive strength of the material when it's fully cured. Standard regular concrete is about 3,000. So that kind of gives you an idea. And this material, it's all hand troweled, it's not sprayed on. Yeah, we'll completely resurface the walls, and that gives it, on average about 50 years more of life. By no means do we always have to do the entire basement. So often it's just isolated kind of bad spots that we need to repair, but every job is different, and we typically don't know the severity till we see what's going on.
And a question.
Yep.
Are there different parts of the state that you typically see? Like, is there any correlation with more sand, more rock, more sediment in the mixtures of the homes pre-1920s? Or is it generally, like on the coast, do you see more sand usage, or is there any correlation from your experience?
I would say not really.
Yeah.
I don't see much of a difference. I could have two 1920s houses right next to each other in downtown or northeast Portland, and one foundation's completely gone and beyond repairable and just horrible, and the foundation right next to it is in like as good a shape or better than you could expect. I mean, it just, every house is very different.
Yeah.
So, yep. This is kind of showing here kind of some what you'd often see, exterior spalling. The foundation has been skim coated and repaired in the past. Probably this is standard 1920s, probably repaired like in the 50s or 60s. And over time, moisture has gotten in behind that skim coating and caused delamination and failure there. So we would pretty much do the same thing, remove all the failed material and reconstruct that area with our mortar. Let's see here. This is showing that same exact wall on the interior. The wall has been reconstructed and skim coated with our special cement, and then 2 coats of an interior gray vapor barrier applied, mainly for blending and to hold out efflorescence. Efflorescence is that white chalky kind of residue material that you often see on brick and mortar and in the inside of basement walls. Efflorescence is caused from exterior moisture vapor kind of wicking through the wall and pulling those minerals out. It's almost impossible to completely eliminate efflorescence unless you were to dig up the entire foundation on the exterior and do membrane work. But this coating really helps to hold out typically 95 to 100% of efflorescence. So does anybody out there have any questions at all about foundation repair or this restoration process? No?
No.
All right, well, we will move on here. Let's see here. This is kind of showing the application of the mortar. The reason why we have to hand trowel it is because it is very, very fast curing. Once we mix up this mortar, it starts to react and cure very fast. In about 10 minutes, it's rock hard. You can tap on it with a hammer once it's mixed. So we're typically mixing this material in about half to quarter bags at a time and getting on the wall very quickly and kind of feathering it out. He's hand troweling it there, and then we'll hit it with a sponge, kind of knock down the high spots, so it'll be a relatively uniform flat finish when we're done. That is a basement of a standard 1920s foundation wall, and it had pretty significant deterioration there. Like I said, especially dealing with older homes, it's unknown for you realtors out in the field with your clients doing walkthroughs and walking through homes, and you start to see damage, how bad it really is. We go into basements and they're, it looks really bad, but it's very isolated, and it's a relatively quick, $1,000 to $2,000 repair job, and sometimes they are more significant, and they're could possibly be in the $20,000 plus. It's just very important to take relatively detailed pictures and give me a call as soon as you see something. So if I'm not available, we do have other people that you can almost always get in contact with while you're there on site. So these are kind of, can they see my cursor? Mm-hmm. My arrow. So this over here, this is actually a commercial building where there is rebar inside the wall, and the rebar was getting damp, rusting, and expanding and kind of blowing out the concrete. So what we did is we removed all the failed material around the rebar, sandblasted and ground down the rebar to bare metal, coated it with a rust preventative, and then we will kind of reconstruct the surface there with our mortar. So all different types of repairs, anything that pretty much deals with concrete. We do driveway replacement and basement floor replacements as well. We also excavate basements to provide more headroom. Often with these older basements, it is partial basement, partial crawl space, which we see often. We have multiple jobs on our books right now for digging out those crawl spaces to extend the basement to have more square footage underneath the home. So, yep. Like I said earlier, we are not a general contractor. We don't do building and remodeling, but for full basement remodels, for giving more headroom or crawl space dig outs, we do have general contractors that we work very closely with, so we can kind of take care and manage the whole project. Let's see here. This is going into more structural and stabilization. New wall is a steel, well, it's not. We were utilizing this new wall system. The system we're using now, this slide is incorrect. It's not called new wall anymore. It's just a steel interior support system. But for seismic stability, especially with like brick and block foundations where we can't bolt to the foundation because it's brick and block, we are installing interior steel support systems. These are fully engineered and permitted through the city to take the full vertical and lateral load of the structure. So essentially it's designed as if the existing foundation is non-existent. If the foundation were to completely fail, the structure would still be supported by this interior steel skeleton type system. Awesome application to be relatively cost effective for a true major seismic and structural upgrade. On average, these systems cost about $250 a lineal foot. So for a full basement with 7 or 8 foot studs, so on average like 100 to 125 lineal feet of basement wall, these systems are like 25 to 35,000. That is a lot of money, but as the other, compared to other options like full replacement or concrete walls, it's about 50%. We can typically install these systems in like 3 to 5 days, and it is fully engineered. So awesome option for more than just a standard retrofit, which is just bolting the house to the foundation. So let's see here. This is actually that picture I showed a few minutes ago with that guy kind of troweling the mortar. This is that job. It was a concrete stem wall in the basement that was pretty failed, and they want to do more than just restoration for aesthetic purposes. So this is a good description, an example of the steel system. It's a steel C-channel top plate that's continuous with I-beam construction studs placed at about 36 inches on center. What we do is we come out and bid and inspect these projects, and then if we, the client wants to move forward with us, we come out there with our structural engineer, and he does his full scale calculations so we can go to the city to get our permits. So awesome, relatively cost-effective, full structural upgrade to the home. So let's see here, kind of a description there. This is the full basement area. We have repaired and restored these walls here. Also up on top, the concrete was all restored, and then the steel support system installed around the perimeter. It pretty much eliminates the house from shifting or bouncing off the foundation if we had a sizable earthquake. So basement waterproofing. So yeah, our company really specializes in foundation repair, restoration, and waterproofing, and they all are kind of incorporated together, but we have some very relatively specialized applications which allow us to waterproof basement walls and basement floors to prevent intrusion. So one of the main applications we use for waterproofing foundation walls. So basements in general leak for 2 reasons. One is water intrusion coming up through the floor, through cracks or the footing joint. The footing joint is the seam where the foundation wall and the floor meet around the perimeter. Whenever you have water seepage coming through the vertical foundation walls, that can be waterproofed. That does not necessarily require a sump pump or drainage work. We do kind of take a look at everything that's going on. Often your downspouts on the outside, your gutter downspouts coming off the roof, if they're not adequately directed away from the foundation, typically a minimum of 15 feet, those absolutely can be a great contributing factor. And sometimes just by installing new storm drains or downspout drain, that can prevent water seepage coming in from an isolated point. But this is showing kind of our urethane crack injection method. This is for sealing and waterproofing cracks and voids in foundation walls. Essentially, we'd come in and do a light chip and patch with a high strength epoxy to the cracks or the voids. What that does is it acts as a dam pretty much to hold our material in the wall. Once that material is cured, we will drill our 1/2-inch holes through our repair to intersect the void behind our patchwork, install our little injection port there. This is an injection port. It's about 6 inches long. It gets pushed into the hole here and the end tightened up, and it kind of expands just kind of like a boat plug would. It has a little rubber gasket, seals itself in there. Then we'll hook up a pump to our Zerk fittings here, or the injection tips, and slowly start pumping a urethane grout foam. This foam is specifically engineered and designed to waterproof and seal below grade foundation walls. It expands at 0 psi, which means it's not going to blow out the concrete or cause more damage, but it expands and works its way outward, which allows us to seal the entire span of the crack and pretty much eliminate that as a void while working from the interior. So all of these applications do come with warranties, typically ranging from 15 to 14 years, depending on what we're doing. Very cost-effective way, especially like a 7-foot crack coming off of a window or a vertical crack in a basement that's leaking. We can come in and literally just in a matter of hours, an average cost of around $1,200 or so, seal up, repair that crack. We're in and out with a warranty, and it's pretty much never going to leak again. Once the injection process is complete, we pull those injection ports, patch our holes, and typically we'll either paint the walls or the client can paint over the repairs for blending purposes. So let's see here. This is showing below slab drainage. So basement walls can be waterproofed. Basement floors cannot necessarily be waterproofed because typically water's leaking in from a hydrostatic pressure situation or a spring in the ground. When water's literally, during prolonged heavy periods of rain, the water table rises and meets the slab of the basement and then pressurizes and comes up through cracks in the floor. We do see this often. That can't be waterproofed to hold the water out. What we need to do is collect that water, give the water somewhere to go, provide a greater path of least resistance for the water underneath the floor, and which that does is eliminates pressure from building. So what we do here is we cut 8 to 10 inch wide trenches in the floor, remove that concrete. We excavate our trenches, typically starting at about 12 inches below the floor. All of the trenches will slope towards a deep catch basin. Let me see here. Yep, so this is a catch basin. Typically they're 32 inches deep. The water will collect in this catch basin, and then that basin houses a sump pump. So once the water enters the basin, the sump pump will discharge the water outside. Typically we will tie into the storm drain system or go out to a small dry well. The sump pumps function by themselves. They just need power to be plugged in. They have a standard float switch, which as the water table rises in the basin, the sump pump automatically kicks on, and then as the water table recedes, it automatically shuts off. So it turns on, shuts off by itself, very little to no maintenance. Once all of our trenches are excavated, we install our 4-inch perforated drain pipe, and backfill with drain rock up to the bottom of the slab, and then all of the concrete is replaced and troweled flat and flush with the top of the slab. So it is typically pretty much a totally sealed system. Often before we replace the concrete, we will install a perimeter water guard. What that does is when we do replace the concrete, it leaves about a 1/2 of an inch gap between our system and the foundation walls. So if by chance the foundation walls ever do leak or leaks in the future, it allows that water to flow down into our system and doesn't come out onto the foundation floor. So these systems on average cost between $75 and $100 per lineal foot. They are typically the most intrusive and kind of worst case scenario for basement waterproofing. So, 100 lineal feet of this drainage system, averages somewhere in the $10,000 range. So it is not cheap, but sometimes it is the only option.
And Justin, are there any homes that, just from your experience that you've seen, that are more, susceptible to needing this type of repair?
It absolutely older homes. So like pre-1950s, the concrete floors, especially in the 1920s and older, the basement slabs are very, very thin. We call them rat slabs sometimes. Like originally the basement might not have had a concrete floor and it was just dirt, and at some point someone poured some concrete down in there and troweled it out, and on average it's only an inch or two thick. And also with older homes, there's typically no footing drains. So around the outside of the walls, before they backfilled, they would put in either terracotta drains or some type of a perforated pipe system. And if those are not functioning correctly, there's lots of different factors that can come into play, but it is common for these homes to have these situations where water is literally percolating up through holes in the floor or cracks or seepage around the perimeter joint where the slab meets the wall. But yeah, it's typically, I would say, like pre-1940s is 90% of the work that the homes that we do this type of application in. As you get newer, especially into the 70s, the concrete's good quality, hard concrete, and we just don't see that as much. So
is there anything, so when you've seen homes that have needed this intrusive of a repair, what kind of tipped the homeowner or realtor inspector off to this? Is it just the presence of water, or are there other signs that people can look out for when in a home?
Yep. So really worst case scenario is if this is a finished or semi-finished basement. Often you'll come in and you'll see, the baseboard has some moisture damage, or it's starting to swell, or there's some dry rot on the bottom of some posts, which is evidence of moisture intrusion. Not always in those cases is it a below slab dewatering system application, but yes, throughout the winter time, people are selling their homes and you go down in the basement and there's a small puddle. The one thing we really need to get out there and really identify the point of entry. So there's no such thing really as a big one thing fix all basement waterproofing repair application. Really determining the point of entry, where the water's coming in and what's causing that, pretty much tells us what application we're going to do to repair that. I know it doesn't sound right, but best case scenario for water intrusion is a crack in the foundation that's non-structural. We can very easily repair that crack. If the water is seeping in through cracks in the floor or at the footing joint, that typically requires some type of a drainage system to alleviate that pressure. So,
great.
Anybody have any questions at all? There's kind of a lot of information here. If anybody has any questions, feel free to chime in. So yeah, we'll move forward here. Let me see. The next part of the presentation here is going to be regarding to exterior waterproofing, membrane work. So this is showing new construction, which all new construction below grade basement walls need to be waterproofed. But often we will do exterior membrane work also on older homes. So let's say there's a water leak in the basement behind a really nice built-in TV stand or something along those lines that we're not going to spend thousands of dollars to demo out to access the crack, or the basement wall is leaking so badly that we really don't feel comfortable or confident waterproofing it from the exterior. So when we're talking about waterproofing foundation walls or below grade basement walls, it is always best and optimal to do it from the outside, but not always necessary. So when we determine it to be necessary to do exterior membrane work, that does include full excavation to expose the entire foundation wall. We will clean the wall, typically using a pressure washer to remove all the dirt and debris, patch and repair the foundation as necessary, and then typically apply 2 to 3 coats of a high-grade liquid rubber membrane. This membrane is specifically engineered and designed to waterproof below grade basement walls. We allow this to cure for 2 to 3 days before we backfill, and then we will typically backfill the bottom 24 inches with drain rock and then cap it off with soil. And this pretty much eliminates moisture contact to the wall to completely waterproof it. The reason why this isn't always necessary is because often the entire wall is not leaking or weeping water. It's isolated bad points like those rock pockets I talked about, or a crack. And I would say that probably 75 to 80% of the time we can, fix the problem by working from the interior. So we're going to kind of move on here, getting away from foundation repair and waterproofing, and go to seismic retrofitting and some drainage. So if anybody does have any questions at all regarding what I've already talked about, I can always go back, but yeah, feel free to chime in. Yeah, this is one more picture kind of showing reinforcing that footing joint to ensure that that doesn't leak. Kind of a good picture there. This job was actually in Hood River, done last summer. So seismic retrofitting, or earthquake retrofitting and seismic strapping. Typically, what this application involves is mechanically connecting all of the structural components to the home together and ensuring that the home is bolted to the foundation. A home is typically supported by either a post and beam system or floor joists. So the difference is, with floor joist construction, you would have, is typically what you see in a basement, where you have 1 or 2 main center beams, and then your floor joists sitting on top of those beams, which support the floor and the structure. In crawl spaces, sometimes we will see post and beam construction, which means that there are no floor joists. There are beams that run the length of or width of the house about every 4 feet. Mechanically connecting all the structural components for us is everything pretty much underneath the structure in the crawl space or the basement. We don't do anything above the foundation. All of the beams, it is very important to make sure that your beam ends are either supported by a good quality support post or bolted to the foundation. I would say the majority of the time, the main support beams are sitting inside of a foundation pocket. It's very important. You can just barely see here. This is a beam sitting inside of a foundation pocket, kind of like this is a beam here and it's sitting inside of a foundation pocket, but this shows a steel plate that allows us to screw up into this bottom of the beam and then bolt it to the foundation. That pretty much eliminates the possibility for that beam to shift out of that pocket and then your floor would sag or collapse. All of the floor joists get clipped or connected to the perimeter sill plate and beams. All of the posts get connected to the beams and floor. It's just mechanically bolting, connecting all of the structural components together to ensure that everything is as stable and sound as possible. All of the brackets that we use are engineered and designed by Simpson Strong-Tie. Simpson Strong-Tie is a world leader in mechanical fasteners, and they build all of these brackets and bolts. Once all of the floor joists and beams are connected, we go through and typically install our UFPs. This is a UFP bracket here. It stands for Universal Foundation Plate. It is the main bracket that we use that actually connects the house to the foundation. They typically get installed between 4 and 6 feet on center around the perimeter. These brackets here were kind of an added bonus. This lady was a little hypersensitive to earthquakes and wanted to do just a little bit extra something besides the standard bolting, and we installed these steel C-channel posts essentially that go down into the concrete or go down below the floor about 3 feet and encased in concrete. And what that does is that's going to prevent the foundation walls from pretty much collapsing inward. The majority of the homes that we retrofit are older homes, and the biggest concern with that is that the foundations are unreinforced, like I said before, which means there's no rebar. So all of these basement walls are also retaining walls with soil pressure pushing in on the foundation, and if and when we have a sizable earthquake, that soil pressure, crushing in on the walls is what is the most concerning. So we can bolt to these foundations all we want, but we are still relying on the foundation to perform. So we do have some applications that allow us to reinforce the foundations, like that steel support system I was talking about, and other steel applications and carbon fiber strips and stuff along those lines to just give the foundation more of a fighting chance against an earthquake. So
Justin, on the seismic retrofitting, are there different types of homes? I mean, do you recommend that every home has some level of seismic retrofitting, or are there some homes that you would really recommend, or how does that work?
So even with brand new construction, there are things to be done that's, an improvement other than just the very bare minimum for the builder to pass inspection. Like typically the post and beams are not mechanically fastened. They're just nailed together. But as we get into like homes built post, 1970, that's really when we start seeing existing bolting. But just by having the sill plate bolted to the foundation alone gives you very little actual seismic stability. If anybody is concerned about earthquakes or concerned about the stability of their home, we just highly recommend just having us come out and take a look and do a full assessment. All of our inspections and estimates are always free. And we'll just come out, evaluate the home, and just discuss with the homeowner kind of some upgrades they can do and really what we feel is necessary. All homes, like I said, pre-1940s are unreinforced. Some of them are significantly worse than others, but they all will not fare well if we have, quote unquote, the big one or a true 8 or a 9.0 earthquake. So we are doing a lot of these interior support systems. The number one priority really is to ensure that the home is habitable after an earthquake, to ensure that somebody can live there, and life safety. So especially if there's a bedroom in the basement or something along those lines, to ensure that the home isn't going to collapse or fall into the basement. If the best construction is slab on grade, if a home actually has no crawl space or has no basement, we don't see those very often here in Oregon and Washington. But yeah, all homes can be seismically upgraded very easily, even if it's a newer home. We do a lot of post and beam work in, the 1990s and even 2000s homes. So.
And have you seen since, this part of the country has been, I guess, seeing an increase in, like scientific studies about the big one coming out or just more media? Have you all seen an increase in business for seismic retrofitting?
Absolutely. So a couple years ago with that big New Yorker article about the big one coming here to the West Coast, our business for retrofitting has probably easily quadrupled.
Wow.
We are doing on average probably 3 retrofits a week. And that's earthquake retrofitting is about 25% of what we do. We do a fair amount of it, but it's not our main focus. Our main focus is the restoration and strengthening of these old foundations. But yeah, we've seen a huge increase of business from that, mainly because people are just more aware of it. So most people, they live in their 1920s house and everything's fine, and they wouldn't know to even think about, oh my gosh, my house is not connected to my foundation at all. So pretty much all 1920s construction, there is zero connection to the foundation. They're literally using the weight of the house to hold the foundation there. I mean, the house is 100 years old approximately and is still there and has gone through some earthquakes, but we really haven't had, a sizable earthquake in recent history. So,
and one more question about this. Is this, so if someone had a home, maybe let's not say it's a 1920s home, maybe it's newer.
Mm-hmm.
It sounds like this could be rather affordable or a good measure to take. What is the price range that you normally see?
So for the full meal deal, like 1,200 square foot basement, unfinished, everything's open and exposed, our retrofits average like around 6,000. So really that's it's a significant seismic and structural upgrade that's relatively cost effective. Most people are like, oh wow, I thought it was going to be 20,000 or more. But yeah, so standard retrofit averages like 5,000 to 7,000. Vast majority of them are in that $6,000 range, and typically it is a one-day job. So
cool.
Yep. Worst case scenario with retrofitting is that it is a finished basement. There are some contractors out there that say they can retrofit the house while working from the exterior with removing some siding and installing those foundation plates. But like I said, again, all of the structural components that are supporting the home is on the interior. And by installing those foundation plates alone gives a great false of security and gives you very little actual seismic stability. So I would say the only time we do any bolting or retrofitting from the exterior. It's on isolated areas around the home. Like I said earlier, if there's some finish work on the inside that obviously we're not going to demo out some custom inlaid, oak TV stand or entertainment center. So maybe along, half of a wall or one wall only, we'll remove siding and install brackets. And then again, it really does also come down to the client's expectations and what they're wanting to achieve and their budget. Nobody really wants to cut open and destroy the inside of their finished basement. So we have those conversations with them and let them know the pros and cons of what their options are. Yep. All right, let's see here. So that's that about earthquake retrofitting. And remember, please call us if your clients have any questions about anything. We're happy to talk over the phone and give advice and comment on specific issues. So exterior drainage, especially with older homes, they're more susceptible to drainage problems because there typically is none or it's failed. This is showing a hillside. There was actually a big mountain kind of coming up here, but everything kind of sloped right down to the back of the house. And this was a big basement down in here, and water would just pool up here and was actually leaking into the basement. When we removed this slab here, there was an old concrete tile drain system here, which is just 18-inch sections of hollow pipes stacked next to each other. It was originally designed for water to enter these points and then kind of flow on down. Obviously, that was completely failed by now. And so what we did is we removed, let's see here, kind of showing that tile drain system there failed over the last 50 to 100 years. This is the system that we put in here. We do have a perforated drainage system going along the outside here, as well as a surface gutter system. We graded this back a little bit, so any water, there's still going to be a fair amount of water coming down this way, but it's going to be collected, providing a path of least resistance for the water and kind of taken down and around the home there. And that pretty much took care of that problem. So yes, exterior drainage systems, gutter or trough drains, French drain systems, and downspouts. The downspout drains are the gutter drains coming down are a huge priority, especially with older homes, to prevent damage and water intrusion. So kind of shows another example. We were actually doing an interior drainage system in a basement and pulled up these drains here that were completely full of dirt. This is a sloping driveway on the left side here coming down into a garage. Installed this little trough drain here to collect that water to prevent the water from, just pretty much flowing right into the garage there. Let's see here. So this is, I guess, going back talking about some foundation strengthening applications we have here. This is actually showing a commercial building. We use and utilize a lot of carbon fiber. Simpson Strong Tie, the company that engineers the earthquake strapping brackets, also engineers this carbon fiber sheeting. This is true carbon fiber fabric, saturated with a liquid epoxy and adhered to a prepped surface. That is to strengthen and reinforce basement and foundation walls, to pretty much lock it all together to prevent it from getting worse. We also have C-channel. That's those C-channel brackets that we have to bolt across cracks, and it's a steel bracket that we bolt to foundations to bridge over cracks and strengthen the foundation. Also, crack lock staples. This is showing kind of installing the fabric to the surface. It is surface adhered with a combination of epoxies and mortars, fully engineered applications to reinforce basement walls. This is a basement wall in a basement. There was a horizontal crack here due to the soil pressure pushing inward on the foundation. So we install these. If the surface is sound enough to install the fabric, we will install these vertical and horizontal strips to reinforce the wall to pretty much eliminate those cracks as a weak point and prevent further damage. So let's see here.
About 5 minutes.
Okay. Crack lock staples. It is a little carbon fiber staple that gets installed embedded into typically a slab. We cut a 2-inch deep groove over the crack, fill that groove with a high strength epoxy, and insert the staple. It's also called crack stitching. Allows us to mechanically connect the crack back together and prevent further damage. Often in a real estate deal, these are very cost-effective applications to pass inspection and to get the job done. Kind of shows it here. That's the crack. The crack will get mortared together after we install the staples, but we cut that groove and install this little crack lock staple. Very cool, cost-effective, kind of quick and easy repair. These are showing some foundation strengthening applications we've done in the past. This is actual 1894 brick foundation in Northeast Portland. Original, had some slight bow to it, was being pushed inward. We installed these carbon fiber strips, and then the foundation was painted. Once the foundation was painted, you almost couldn't even see our repair. It was awesome. But you know, relatively cost effective just to extend the life of the foundation and prevent further damage. This kind of shows an industrial plant also in Northeast Portland. We wrapped these columns with carbon fiber to prevent further damage. This is a very good description and example of carbon fiber staples. This corner was kind of broken and falling apart. These were cracks right here. The cracks have been demoed out and patched, and then the carbon fiber epoxies or staples embedded into the foundation to just kind of bond that whole crack together. This is a foundation strengthening application that is called FRCM. It is just specifically engineered and designed for older homes to reinforce the walls. It is a continuous carbon fiber grid that gets mortared onto the wall to prevent the walls from caving inward. The reason why we have so many applications is because it comes down to the client's expectations, what they're really wanting to achieve, and their budget. So like these FRCM jobs, if we're doing all 4 walls on a standard like 12 to 1400 square foot basement, those were $50,000 jobs. It took us about 2 weeks, but not often does the clients have $50,000 to put into their foundation, and we could maybe do something that's not quite as structural. So then again, you know, we really need to come out and assess the problem and situation and kind of come up with an application that kind of fits everybody. I do have a little video. Do we have time to watch a little video on this, or we don't really need to? I do have a little video that shows the application of the FRCM. We'll play here, and that'll wrap us up. Is that?
My name is David Arana, partner and project manager with Western Construction Systems. Western Construction Systems is a local specialty foundation contractor. We've been servicing Oregon and Washington for over 32 years. And one of the things that we do a lot of is foundation strengthening and earthquake retrofitting. Today we're at a home in Northeast Portland, turn of the century, 1920s foundation, and we're doing what's called FRCM. That stands for Fabric Reinforced Cementitious Matrix. FRCM is a product of Simpson Strong-Tie. It's been launched in the US the first of this year, 2018. And what FRCM does, it allows us to embed a specialty grade of carbon fiber between two layers of a high-strength structural mortar, and that increases the lateral and seismic resistance of these older foundations. So right now, these foundations have no steel, they're not reinforced, and this technology allows us to give the foundations a fighting chance against an earthquake. We can actually increase the seismic resistance and lateral resistance of these older, unreinforced foundations. FRCM has been used in Europe for about the last 15 to 20 years, reinforcing unreinforced concrete foundations, commercial, residential, industrial, mining tunnels. We're always looking for the cutting edge, most innovative technology, and also the most cost-effective solutions to reinforce older foundations. There's not a lot of solutions out there that allow us to truly reinforce and seismically upgrade unreinforced structures that's cost-effective. FRCM is that solution. The application of FRCM does require bare concrete. We've been here for about a week prepping the surface. We shot blasted the concrete. We ground and chipped away any existing old patches on the wall. The next thing that we do is hydrate the wall. For about 24 hours prior to application, we'll be down here spraying the concrete with water. We want as much water in that substrate as possible for the application when we actually install the shotcrete. When we do that, we actually spray on about ½ an inch of the mortar on the wall, and then we embed this carbon fiber grid into that, and then we'll encapsulate it with the second layer of the mortar, hit that with a curing compound, and then let that cure for about 24 to 48 hours. When we're done, the amazing thing about FRCM, it gives us a lightweight structural shell on the foundation that really can eliminate the ability for the foundation to just crumble in an earthquake, and it increases the lateral resistance to the foundation. Because these foundations are, of course, designed to take the vertical load of the house, but they're equally a retaining wall, retaining the earth and the pressure of the earth on the other side of the wall. That's why a lot of times we get these horizontal cracks in the foundation. So when we're done with the FRCM reinforcing to the actual concrete foundation, we're going to be performing a full voluntary seismic upgrade in this house, basically bolting the whole structure to the foundation. This is what we call a universal foundation plate. It's one of our primary perimeter foundation straps. Basically, it screws to the sill plate. That's the bottom board that sits right on top of the foundation, and then it'll bolt right into the foundation. It'll look right like this up here. And there's one of these plates about every 4 to 5 feet around the perimeter. We also connect the center support, the beams, and the posts together to make sure they don't move. When we're done, this will be a fully upgraded, reinforced foundation and seismic upgrade. Here at Western Construction Systems, we promise you 3 things. We're going to be honest, reasonable, and we try to think, what would I do for my house? For any more information about FRCM or any more of our foundation repair methods, give us a call at 503-362-5052. You can also reach us on our website at westernconstructionsystems.com.
All right, so I hope I was able to be informative. I know we went over a lot of information. That's pretty much, you know, the vast majority of what our company does, everything foundation related, structural and drainage. So if anybody has any questions at all, please feel free to call me directly or get in touch with our office. We look forward to possibly working with you in the future. Thank you.
Thank you.